Good morning all. Today we are going to discuss about the transient response for DC. In that we are going to discuss about the RLC circuit. I think for the last class we have discussed about RC and RL. In that I have given in this PPT, that is we are discussed in the short equations only. That is we have going to write in the exam. We need to write all the information in deeply, but for the short information I'll giving the short form equations only, and likewise for the RLC also we have to discuss. So before enter into the session, we have to recall resistor, inductor, capacitor, and these are the storage element, we know that, and L stores in the form of magnetic energy, and C stores the energy in the form of electric energy. And obviously we know that resistor is dissipate the power, and these two are storing the energy. And this is the topic we are going to discuss. It is second order system, characteristics equation, damping ratio, and the types of responses. And this is the circuit we are going to discuss. RLC, that is RLC are connected through the source, and there is a switch will be there. We know that what is transient. Transient is the response of the circuit based on the switching is close or a sudden change in the circuit based on the input. So if you are closing the switch, initially it is open. When it is closed the switch, there will be a current flow in the circuit. So if you are seeing the closed loop, definitely we will apply in the KVL. So equation KVL we have to write. After that we have to take a Laplace form and inverse Laplace form, and then we go for the equations analysis, and along with this we are analyzing the characteristics. When t is equal to 0, what will happen, and t is equal to infinity, what will happen, and when it is changes, and what are the changes in the characteristics of the circuit, and when it is reaches the steady state, all those things it shows in the characteristics. So when we are applying the KVL, VFS is equal to RIFS LS into IFS plus IFS by CFS. From that we are calculating the value of IFS, and the characteristic equation is already we told that is the second order, because RLC are together, we are analyzing the second order only. And damping conditions, we know that three type of damping are there. One is underdamped, overdamped, and critically damped. Underdamped, there is a initial stage, the oscillation will be more, and steady state will comes under the later. And critically damped, it is reaches steady state shortly, and overdamping is the oscillation is less, but comes under the steady state is taking minimum time. So which one is best? You have to say the critical damping is best. So based on this, we are defining the equations. So overdamped alpha is greater than omega n and less than omega n, and which is equal to 0. So and these three damping are shown in the characteristics equation. And critically damped response is I of t is equal to a plus b of t into e of minus t. For overdamped also we are writing the equation I of t, and for the overdamped also we are written, and this is the empathize part, and this is the defined dt defined part, and application of this equation is, that is power system switching, communication system, tuned circuit, resonance network, and this surge networks. So second order system characteristics equation, damping ratio, and the system response we have discussed. So damping ratio means that we are discussing three damping ratios. One is underdamped, overdamped, critically damped. Critically damped means alpha is equal to omega n, and less than or greater than to the alpha. We are saying it based on this we are classify the types of responses. These are the summarization we are giving in this session. and we see a few applications also, and these are the references based on the topic. Here I have to list it, so we have to see in the next class. Thank you.